Hello guys, yeah, welcome back to my channel. This is Chemistry Corp. It's been a while on my channel, so today we'll be talking about the E and the Z system configuration of alkene. So before we move to that E and Z system configuration of alkene, we all know that for every alkene there are unsaturated hydrocarbon. So now for every alkene we know we have this particular bond, so they have a double bond. So if we are to talk about this E and Z system, we should have understand what we mean by isomerism. I've discussed that in my previous video under isomerism. So today now we are moving to the E and Z system of alkene. So the first thing you are going to check about is that you must assign priority to the two substituents on each of the carbon of the double bond. The second one is compare the location of highest priority of each carbon atom. So E stand for the opposite side now, which can be taken to be the trans, while the Z, the same size, can be taken to be the what? The cis. So when talking about this, we must understand what we call by the cis and trans. So don't forget, your cis is your what? Your Z, while your trans is your E. So I'll be using three examples to explain the highest priority of this. So now the first thing is I have A, I have it in this form. Then I have DA, I have CA, I have B, or let's put it like this. We have B, we have C. So this is how it goes. Are you with me now? This is how it goes. We have A, the same thing here. We have B, sorry, we have C here, we have B here, we have D here. So now what we want to check here is that we want to look at the one with highest priority. So alphabetically now we know that our A has highest priority than B. So we name this one 1, but this one will be what? 2. So go back to the second one. Your C has highest priority than your D. So we have 1 here, we have 2 here. So now if they are opposite to each other, are you seeing this form now? So we can take it to be the what? The E system. So let's move to the second one. A has highest priority than B, we have 1. This one is 2. C has highest priority than D, we have 1. We have 2 here. So they are facing each other, that is they are opposite. So we can take this one to be our Z system now. So you can see that it's very simple for you to identify your C and E system. So now let's take a look at 3 good examples now. If I should have a methyl group here, a double bond is here. I have ethyl group here, or let's say I have boron, so we have our H here, then here we have methyl group here now. So a question like this, are you with me now? A question like this, if you have to look at the one that has highest priority, we all know that to the series of the halogens, the bromine has highest priority than hydrogen atom. But so here now, we are going to look at the one that has what? The highest atomic number. Again, the one that has highest atomic number, to give the number to each of it now. So bromine has high atomic number than hydrogen. I will take this to be 1. Why this one to be what? 2 now. So let's make justice today. Don't forget that this one is what? Ethyl. So this one is what? Methyl. So now, don't forget now, from this carbon atoms here to this, don't forget that your carbon atom here has 3 outside electrons. One will be attached to it to form this bond now, this single bond here. So the other 3 is going to what? Take the place of these hydrogen atoms here. So this one here now, this carbon atoms here, we have 1 here. So the other 3 will what? So this, there's one outer electron that will bond with these carbon atoms here. So because of this bonding with these carbon atoms here, it's telling you guys that what? This ethyl has highest priority than methyl. That is, it has highest atomic number than methyl. So I have 1 here. So you can see the one are facing each other. They are opposite to each other. So I can take this one to be my what? The Z system. So when identifying the E and Z system of configuration of alkene, you check the one that has highest priority. Are you with me now? If you can't check that, you check the one that has highest atomic number. So now let's take a look at this. Now I have fluorine here, I have bromine here, I have Cl here, and I have what? Iodine. So with what you have here, we want to look at the one that has highest priority. So yeah, if I to look at the one that has high priority, you might miss it now. So let's go with the one that has what? The highest atomic number. So this one here, chlorine has highest atomic number than fluorine. This one is 17, this one is 9. So we take this one to be what? 1, this one will be what? 2. So iodine has highest priority than bromine. This one is 1. That's because of the highest atomic number of the two. So this one is what? 2. So you can see that chlorine and iodine, they are opposite to each other. So we can take this one to be my Z system. So if we have another example now, we have this. The same thing you have there, that your fluorine is this form. Then I have my iodine here, I have my chlorine here, and I have my what? Bromine here. Don't forget that this has highest atomic number than this, so I will name this one to be 1. This has highest atomic number than this, my iodine, to be 1, 2, 2. So you can see now, looking at what you have here, they are alternate, so they are opposite to each other. Don't forget this one, they are on the same size. Are you with me now? Why this one, they are opposite to each other, so we take it to be what? E system. So now, so when talking about this E and Z system configuration of alkene, you know, I told you guys earlier before we move to the examples that you must have understand what we call isomerism, and that isomerism will be under the word the geometric isomerism when we talk about the cis and the trans. So now, under the cis and trans, I told you guys that for every cis isomer, that is a Z, it will be on the same size. So while for every trans isomer, the E, they are always opposite or alternate to each other. So guys, don't forget to subscribe, watch, like, dislike. Thanks.